Okay, now we're going to learn about the transformations required for both AS and A2 maths. There's basically three different types: stretches, reflections and translations, stretches in the Y direction, in the X direction, reflections in the X axis and in the Y axis, and translations in the Y direction and in the X direction. So first we'll have a look at translating, and firstly in the X direction. And usually the best way to do this is to pick a point. Now I'm going to start off with this point here at the origin. We're translating 2 units in a positive X direction. This is the function y equals x cubed, and the effect that this translation, and we'll describe it as translates by, and then I'm going to use a column vector to describe the movement in the X direction, which is +2, and it doesn't move in the Y direction, so we put a 0 there. And the effect that this translation has is to change y equals x cubed to y equals x minus 2 all cubed. Why the minus sign? Well, the sign does change when we translate in the X direction, but if you consider any of these points, like here for example, we have the point 3, 1, and that changes from the point 1, 1. And if you try different X values in here, you'll see that it would be 1 cubed to give us the 1 here, but here it needs to be 3 minus 2 cubed to give us the Y result of 1. So that's why X needs to be 3. At this point here where it's 2, 0, 0 cubed gives us Y as 0 here, but X would need to be 2 minus 2 to get the result 0. Okay, this one's a lot more straightforward. What we're now aiming to do is to translate 2 units in a positive Y direction. So again, if we start off at the origin here, and we're moving +2 in the Y direction, so that point moves to there. This point here at 1, 1 moves to 1, 3. This point here at -1, -1 moves to -1, 1. So you can see here that the Y value has increased by 2 for all of these points. And Y equals x cubed, and the effect that this time it has is it just goes to Y equals x cubed plus 2. We're just adding 2 on to the value of Y. So for the same X value, Y is 2 more. And we describe that as translates by, and again I'll use a column vector, doesn't move in the X direction, so 0 there, and it's just +2 in the Y direction. And this time you'll notice that this is positive, and so is this. Now we'll look at the 2 stretches. This time, if we start at the origin, at this point here, actually, because we're stretching in the Y direction, we're stretching the distance from the X-axis, we're doubling the Y value. Because the Y value is 0 here, that point will stay the same. But this point here with a Y value of 1 will go to 2. So where X is 1, instead of going 1, 1, it now goes to 1, 2. here where we've got minus 1, we double, so minus 1 times 2 gives us minus 2. And in actual fact, we double the distance of all of our y values. So we end up with a curve where all of these distances are double the distance for the original. So here we see we had a distance there of 1, and we now have that distance of 2. What does this mean in terms of the whole function? Well, y equals x cubed, and what that then means is that that maps to y equals 2x cubed, because we're just doubling the value here. So the second stretch is a stretch in the x direction, a little bit harder to understand. Again, at the origin it makes no difference because the x value is 0 here, but the effect that a stretch of 2 in the x direction will be the same, but in an x direction. So that distance there will then double to that distance there. This distance here, and we're looking here at the x distance, so we're looking at from the y-axis, will double to there. And the same will be true of every point on the curve. The distance from the y-axis will double, because that's 2. And what we do is we put 1 over 2 in front of the x, bracket it, and cube it. So that's actually the function we get. How does that work? Well, we want to get this point here. We want the y value of 1. Well, it's 1, 1, so we get 1 cubed is 1. Here, we need it also to be 1 cubed, so, but it's actually 2, isn't it? So it's a half of 2 that gives us 1. So we get the same y value. Two reflections next. We'll start off reflecting in the x-axis. So the effect that a reflection in the x-axis has is that we use the x-axis as a mirror line. So from here, if we say pick that point there will go to there, and we end up with this curve getting reflected like that. And the same will happen here. This point here will reflect to there, so we end up with a point here, and we end up with a curve here. The effect that reflecting in the x-axis has, well, what we're doing is we're changing the sign of all our y values, aren't we? So we've got the same y value for the x value, but negative rather than positive. In this instance, it starts negative, it becomes positive, it goes from -1 to 1. In this instance, from 1 to -1. So we just put a minus in front of the whole thing. Reflecting in the y-axis actually ends up giving us the same result, but it's a different logic. If we pick on this point here again, it doesn't reflect to here, it reflects in the y-axis to over here. And in fact, that whole curve there, that part of the curve looks like that, and we end up with the other part of the curve here looking a bit like that. So you can see the result is the same as reflecting in the x-axis for this particular function, but the way that we do it is different. The way we explain it Well, y equals x cubed maps to y equals, and it's the x values that are changing sign, so we actually bracket that and cube it, but because it gave us the same result as cubing first and then making minus, that's why the two functions when reflected look the same. Okay, now it's your turn. Have a go at these two translations and two stretches, exactly the same as what I've just shown you, but it's with this function up here at the top, this quadratic. Try drawing them and also try and see if you can work out what the equations are. Pause the presentation, have a go. Okay, so now have a go at these two reflections. Right, this is what you should have got for these. Reflecting in the x-axis, well, the effect that that has, if you think again about the vertex and the x-axis as being a mirror line, then this point will be the same distance above the x-axis as it is currently below. These 2 points here that are on the x-axis won't change, and it will basically have the effect of the parabola changing its shape like that, from U-shaped to this shape, which we recognise as a negative x squared. We started off with y equals x squared plus 2x minus 2, and the effect that reflecting in the x-axis has is it makes the whole thing, so if we bracket everything, makes the whole thing a different sign, which then gives us minus x squared, which is what we'd expect from this shape. That becomes minus 2x, and then we end up with plus 2 at the top here. Reflection in the y-axis, well, what you need to think of here is this point moving to there, this point here moving to the same distance there, and so you can see what's going to happen here. This point here will move to about here, won't it? And you'll end up with the same shaped parabola, missed the point a bit there, looking a bit like that, reflected in the y-axis. And the effect this has is y equals x squared plus 2x minus 2 now becomes y equals, oh, what's that? Y equals minus x bracket squared, and then it's plus, and then instead of 2x it will be 2, and everywhere x occurs it becomes minus x, and then minus 2. So the only actual change will be this term, so it becomes, because minus x squared, all squared becomes just x squared, doesn't it? If you square a negative, it becomes a positive. We then get minus 2x minus 2. So the only change is this change of sign here, and that just gives us this parabola here. Okay, if you were successful with your attempts at this, then you're ready to move on. Otherwise, certainly worth having a look through what's been done in this video. Maybe a good idea to have a look on My Maths or in the textbook at the topic. We will be reinforcing this in the lesson, in fact over the next couple of lessons. I appreciate that this is quite a difficult topic, so we will be going over it in some detail over the next couple of lessons.